Okay. So first, I ask you to prepare 4 chapters, right? In that chapter 4, D and F block elements, chapter 5, coordination compounds, and chapter 9, amines, chapter 10, biomolecules. Now, I have written the key points for chapter 4, the D and F block elements. So, what are the main points we must thorough? From which area questions will come, right? That only I highlighted on the board. Actually, we can divide the chapter in different categories. In first category, D block elements. In D block elements, what are the basic things we need to know? First, general electronic configuration, okay, and electronic configuration of elements for atomic number 21 to 30, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc, right? So for all the elements you must thorough the electronic configuration, particularly for chromium and copper. In that a small change will be there. So for chromium 3d5 4s1, copper 3d10 4s1. Why the electronic configuration is changed from the expected? It's a reasoning question. To attain the stability. To attain the stability. And one more thing also you can include that introduction part. So introduction part of D block elements, which includes some alloys, bronze, brass, right? Which combination is that? And why D block elements called as transition elements? Why D block elements called as transition elements? And which elements may not considered as a transition elements? Which means zinc, cadmium, mercury may not consider as a transition element. That reason also you must know that. Actually for transition elements, minimum which need one unpaired electrons, which means free electron is required in d orbital. In case of zinc, cadmium and mercury, there is no free electron. That is not the complete answer. In ground state and higher oxidation state also. So zinc, you know the configuration 3d10 4s2. When you remove 2 electron in the s orbital, zinc 2 plus. Zinc 2 plus also have 10 electrons in d orbital. So why zinc, cadmium, mercury may not consider as a transition element means which do not have free electrons in ground state and higher oxidation state. So those points also very important in the introduction part. So I have missed out that here. And periodic trends. Periodic trends means atomic radius, atomic radii, and ionization enthalpy, electron affinity, electronegativity, right? Here particularly the atomic size and ionization enthalpy or ionization energy, which is very important, right? Because nowadays they are asking graphical representation type of questions. You may be asked, show that variation of atomic size from atomic number 21 to 30. Or else instead of 21 to 30, you may be asked in 3D series. So from scandium to zinc, right? Usually we used to represent scandium to zinc, but you should be very clear. Show the variation in transition elements, which means you should not include the scandium and zinc. You should start from titanium. You should complete with copper. So don't forget that. Graphical representation question from D block means you should be very clear. Question is for D block elements means you should start from scandium and you should finish with zinc. For transition elements, you should start from titanium, and it should end with copper. Is it clear? So gradually the size, what will happen? Increase or decrease? From left to right decreases. You have to show the variations. Roughly you can show that. Roughly you can show and you can point, right? As a scandium, titanium, whatever the elements. Gradually, continuously you can mark on the straight line. And ionization enthalpy. In ionization enthalpy, definitely you will have graphical representation and also reasoning question. What are the reasoning questions? You may get reasoning question compared with chromium and manganese. Chromium and manganese, right? So chromium also have stable configuration and manganese also have stable configuration. Copper also have stable configuration. So when stability increases, ionization enthalpy also increases. Actually, ionization enthalpy, what we are expecting, that should gradually increase from one atom to next atom. But in case of chromium and copper, that will have little bit high. The reason is some extra stability. And don't forget, whatever the question comes as a reasoning questions, write the electronic configuration. From the electronic configuration, you can show the stability of the compound, stability of the metal atom, and you can write the answer. So including graphical representations, right? And then properties. So what are the properties we have in this chapter? So variable oxidation state. Transition elements shows variable oxidation state. And sometimes you may be compared the boiling point and melting point. Actually maximum melting point, because we are studying about metals, right? So melting point only. You will be given with the two metals, one have low melting point, the other will have high melting point. Or else in general trends, melting point is very high. That like you may get your questions. See, when melting point will increase, for melting any metals, we need to give the heat energy. If the heat energy is sufficient to convert solid into liquid, right? That is a melting point. If what the temperature is required, that will increase as, then melting point also increases. When maximum heat energy is required, when the solid is very, very strong, right? Here also stability. Stability attained due to the strength of the bond, metallic bond, right? And also it form complexes, form colored ions. Colored ions are colored compounds, form alloys, form interstitial compounds. Actually, for these four properties, complexes, colored compounds, alloys and interstitial compounds, you need to write the conditions. In which condition it will form complexes. In which condition it will form complexes, right? For example, copper sulfate react with ammonia. Copper sulfate react with ammonia. Just we are guessing only. We will get a complex, tetraamine copper 2 sulfate. It's a coordination complex, right? Sometimes you may be asked, when copper sulfate react with ammonia, excess of ammonia, that is important, right? Give complex, justify your answer. Actually, usually transition elements form complexes. That only we prepared, we studied, right? The same question they can twist. Copper sulfate, copper is there, right? You must know that copper belongs to D block elements, transition elements. It forming complex, that is the question, with excess of ammonia. Then what the point you have to write? In generally, what are the points you will write? Transition elements form complexes. The same point only you have to write. For forming complexes, the metal atom need vacant orbitals, vacant d orbitals, right? And larger surface area. Readily accept electrons from the ligands. The same point only. Actually, in general, when they are asking, you should write as metals. Particularly for copper means change the word metal by copper, that's all. And act as a catalyst. For catalyst, what are the properties, conditions? And electrode potential. Based on the electrode potential, you may be asked, this one is more reactive, that one is less reactive. You will be given with one table, that reduction potential table. From that, two electrode reactions will be given. Which one is gives more reactive? That kind of questions you may get it, right? You know already, you studied in 10th standard, potassium, sodium, in such a way only that will become, right? Which one is more strong reducing agent? Lithium only. So more reacting is more reducing power. More reacting is more reducing power. From that you may get an idea. Suppose they are comparing zinc and copper, which is more reducing capacity. Zinc is oxidizing, copper is reducing, right? The same thing. And next one is compounds of second heading, compounds of D block elements and its oxidizing property in acidic medium and alkali medium or alkaline medium. Actually, two compounds only we have, K2Cr2O7 and KMnO4, potassium dichromate and potassium permanganate. In potassium dichromate, we are starting with chromite ore. That preparation is very, very important. Three equations we have, right? In that first equation, second equation also you may be asked. Directly they can ask, how will you prepare potassium dichromate from chromite ore? Or else convert chromite into potassium dichromate. Or else convert chromite into sodium dichromate. First two equations. And convert sodium chromate into potassium dichromate, which means second equation and third equation. Sometimes the three equations left side alone will be given. For example, chromite, first step is conversion of chromite ore into sodium chromate. That conversion alone will be given, only left side, right side will not be given. That is one question. The other subdivision, that oxidizing property. When potassium dichromate, presence of sulfuric acid, I minus, what is the product? Is it clear? So oxidizing property as well as preparation. KMnO4. In KMnO4, it may be prepared from laboratory, commercial method and from MnO2. Three method of preparations we have for KMnO4. Be careful. The three methods you must know. Very simple. Only one step only. Only one step only for the three methods. And structure of dichromate ion and manganate ion is a tetrahedral geometry, right? And one more thing, in dichromate, see, when you draw the structure, you can find out how many metal bond is there. Metal, oxygen, metal, which means 2 chromium is there, right? Actually, they will ask question from Cr2O7 2 minus. Is it clear? Cr2 O7 2 minus, in which how many metal bond, how many metal oxygen metal bond, how many metal oxygen bond is there? See, chromium. Now how many oxygen is there? 6 only, but it needs 7. So where it will come? Between the metal, right? So make it very clear, the structures also very, very important. Structures and all, yet now they not asked, but this year onwards we are expecting, right? And third part of this chapter is F block elements, lanthanides and actinides. Here also you must surround general electronic configuration of 4F block, which means lanthanides, 5F block elements, actinides, and chemical properties of lanthanides. Maximum students, they are not focusing the chemical property. Actually, if you see that in textbook, it is given from like a circle, this like only given, right? Lanthanum reacts with oxygen, lanthanum oxide. Lanthanum reacts with carbon, lanthanum carbide. Lanthanum reacts with nitrogen, nitride, reacts with water, hydroxide. Right? Their chemical properties also you must have a look of that. Very easy only. And what is lanthanide contraction? Regular decrease in size of M3 plus ion from lanthanum to lutetium. This is called lanthanide contraction. Similarly, regular decrease in size of M3 plus ion from actinium to lutetium, which is called actinide contraction. And what is the cause for lanthanide contraction and actinide contraction? Imperfect shielding of 4f orbital. Right? Actually, that's also wrong only. See, imperfect shielding of 4f electron by one another in the same shell, same subshell. Actually, that 4f orbital we have, right? F orbital maximum 14 electrons can occupy. So that electrons not shielding properly in which orbital? 4f subshells, right? Imperfect shielding of electrons by one another in same subshell or in 4f shell. The same thing for actinide contraction. Imperfect shielding of electrons by one another in same subshell. And what are the consequences? Basic character decreases, covalent character increases, size also decreases, acting as catalyst. Very difficult to separate the lanthanides. So these are the consequences. And difference between lanthanide and actinides. You can write, these are called 4f block elements, they are called 5f block elements. You can write the general electronic configuration for lanthanides and actinides. And here, lanthanides form lanthanide contraction, actinide will form actinide contraction. Here, imperfect shielding of 4f orbital, imperfect shielding of 5f orbitals. This one is less basic, actinides are more basic. And here lanthanides except promethium all are non-radioactive, actinides are radioactive. Actinides form oxocation, lanthanides do not form. So these many points you can write for the difference between lanthanides and actinides. And at the last, applications of D block and F block elements. What are the applications? Actually, we mentioned that D block elements acting as a catalyst, right? Haber's process, Fe act as a catalyst. Contact process, vanadium pentoxide act as a catalyst, right? Similarly, some examples they have given. And catalytic hydrogenation of olefins or alkenes or vegetable oils. So that also you must learn that. And F block elements only you have mischmetals and pyrophoric alloys. Mischmetals and pyrophoric. So that's all about this chapter. Once you thorough all these areas, surely you will get 7 out of 7. And in case